Hey, welcome to week 2 in Math for Elementary School Teachers. I just want to give you a quick overview of this week's chapter, which is logic. Be sure to check out the learning outcomes, start reading the book, check out the videos, and then get started on the homework. So here are like my quick overview here. In logic, we try to take language and distill it down with a little bit of math, because there's things, words we use, phrases we use that always work the same way, like the way we connect things with and, the way we connect things with or, the way we say not, the way we say things like if it is my birthday, then I will have cake. So these are all special logical things that can give us a lot of information to analyze. Specifically, arguments is what we're going to get to toward the end of this section. You'll see some symbols going on there. So sometimes you'll see a set of symbols like this one right here. So A with this upside down V thing and then a B. And somehow we're supposed to know that A means avocados in this case and B means beans. So A, that says A and B right there. So A, avocados and beans. But the A could be a lot of different statements. Like the A could be, it is my birthday. And the B could be, I will have cake. So again, we're going to use symbols to stand in for words or sentences or phrases, and then analyze those. Sometimes phrases are more complex. So anytime I throw an or a not, I can also use combinations of those, like this one right here says A and not B. This one right here says A and B are together first, and then we have an or C after. That's kind of like this statement right here. Go to the store and get beans and rice or avocados. Now that statement's kind of vague because it could mean a couple of different things. If I throw a comma here, then you're definitely going to get beans. Then you could get rice or you could get avocados to go with the beans. If I put the comma here, then that would mean you can get beans and rice, or you could get avocados. But if you get avocados, you're not going to get beans and rice. Okay. So without the comma, it's kind of vague. The comma here is like the parentheses above there. So when I put the comma in that spot, then that would be this logical statement right there. Putting parentheses around the A and B have to go together. If I move the comma, then that would be a different logical statement. A very popular kind of logical statement is what's called an implication. So if this happens, then that happens. Like if it is my birthday, then I will have cake. I like cake. I like birthdays. On my birthday, I definitely am going to have cake. Okay. But sometimes I will have cake and it's not my birthday. And there is a possibility that it's my birthday and I'm not going to have cake. So I have two different statements here. So the I will have cake would be my Q statement, and the it is my birthday would be my P statement. And we'll analyze for if then statements. Well, what happens if the first one's true and the second one's not? What happens if they're both true? What happens if they're both false? What happens if the first one's false and the second one is true? To help us analyze those things, we're going to develop what are called truth tables. So here's a truth table for and here I'm just going to use beans and rice. So if I got beans and I also got rice, then it's true that I got beans and rice. If I got beans, true. If I didn't get rice, then it's false that I got beans and rice. Right? Makes total sense. So some of these are pretty obvious, and some of them aren't. The or one's a little different. When we use or in logic or math, it's what's called an inclusive or. Like if I tell my kids, you could have ice cream or cake. That's an exclusive or, meaning if they choose ice cream, they're not going to get cake, or if they choose cake, they're not going to get ice cream. In mathematics and logic, the or is inclusive, which means ice cream and cake together also fits the or scheme. So that's an interesting idea, a little different than we use it in regular language. Here's a truth table for an implication, and more on that later. Here's a truth table for not, parentheses A and B. Now, since this one mixes a few different connectors for a compound statement, what we often have to do is analyze, say that the order of operations, analyze the inner part first. So that's this column. Once I figure that column, I can negate it, which means pretty much take the opposite. So true becomes false and false becomes true. So logic, these truth tables can be helpful in trying to analyze very complex statements based on what we know about the simple connectors like and or not if then. Some things related to the implication are a converse of an implication, where we just switch the premise and conclusion. The inverse of an implication, where we negate the premise and we negate the conclusion. And a contrapositive is where we do both the converse and the inverse. More on that later. That's a really interesting thing, the relationship between the implication and the contrapositive. So again, read about this. There'll be more videos coming. Arguments. An argument is when you take several statements, often two implications or more, and you put them together to get a brand new implication. Like, if you study math daily, then you will do good math. If you do good math, then you will pass your class. Now, since the conclusion of this one matches the premise of the next, then I can put those together for a new valid statement here. If you study math daily, the beginning of the first one will then connect to the end of the last one, and you'll pass your math class. But a lot of times people string these implications together in ways that are incorrect, and it's not obvious until you really stop and think about it. I'll come back to this later. Here's just each of those statements right there, the first premise, the second premise, and the new conclusion stated as a contrapositive, because a contrapositive is a pretty powerful statement. And then common logical fallacies. So people make these statements in the media all the time, and some common things people say that are often false to try and lead people along somewhere on purpose or by accident. There's one called ad hominem. There's the appeal to ignorance, appeal to authority, appeal to consequences, false dilemma, circular reasoning, straw man, post hoc. Correlation implies causation. There are many others in the book. We just covered those. There's a great website called yourlogicalfallacyis.com, and we'll check that out later. So this is just a quick introduction to the kinds of things we're going to look at. And the goal of this chapter is to be able to analyze complex arguments and to look at some common false arguments people put forth often in our lives. Thanks, and do good math.